While the world's eyes were on the battle between BYD and Tesla, who would offer more range, who would build a cheaper EV first, another giant was working quietly behind the scenes. General Motors, or GM, was secretly developing a technology that could shake the entire auto industry to its core. Now the curtain has been lifted. GM has recently introduced an engine that is neither a conventional electric vehicle, EV motor, nor one that runs on traditional petrol or diesel. Instead, it's a zero-emission engine that breaks the boundaries of both worlds. This isn't just a step forward in technology, it's a revolution in thinking. Experts believe this engine has the potential to render both EVs and internal combustion engines obsolete, changing the very definition of the automobile. Many say this could be GM's biggest game changer. If it succeeds on a large scale, it may pave the way not just for the future of cars, but for the entire energy sector. So the question arises, is this really possible? Could a third player now win the race between Tesla and BYD? Before diving deeper into GM's revolutionary idea and this silent, strategic move, make sure to subscribe to the channel to stay updated on the latest in technology. For years, GM has been searching for an alternative to electric vehicles, something that's not only environmentally friendly, but also offers long range, low cost, and freedom from heavy charging infrastructure. In this quest, they found renewed hope in an old but largely overlooked innovation: compressed air technology. Yes, you heard that right. Air as an energy source. The idea isn't new. In the late 1800s, several European cities, notably Paris, used compressed air technology in trams and mining operations. However, as petrol and diesel engines proved faster and more powerful, air-based systems faded into obscurity. Around 2010, Peugeot revisited this idea and attempted to integrate it with a conventional engine. Their hybrid system showed promise, delivering eco-friendly performance without relying on a battery. Unfortunately, it never moved beyond the experimental stage. GM, however, took the concept seriously. They recognized that if developed properly, compressed air technology could not only rival EVs, but potentially change the automotive industry entirely. While the world was rushing toward electric vehicles, GM began investing in research and development of compressed air engines, quietly, strategically, and with long-term vision. So how exactly do compressed air vehicles work? If you're imagining something similar to a battery or a gasoline engine, think again. The mechanism is unique and surprisingly clever. These vehicles neither burn fuel nor rely on bulky, expensive batteries. Instead, they run on pressurized air. The core component is a compressed air engine, also known as a pneumatic engine. On the outside, it may resemble a traditional engine with pistons, cylinders, and valves. But inside, it works entirely differently. There are no explosions and no flammable fuels. High-pressure air is released into a chamber, pushing the piston forward with force. Once the air is released, a spring pulls the piston back. This back-and-forth motion drives the engine, turning the vehicle's wheels. The result? No smoke, no toxic emissions, just clean mechanical efficiency powered by air. What's even more fascinating is that the basic structure of this technology is quite similar to traditional engines. That's one of the reasons companies like GM saw potential in it. They realized they could develop it quickly using existing production infrastructure and technologies without having to reinvent the wheel. Now that we understand how the compressed air engine works, the next question is, what makes it so special and potentially better than electric or fuel-based engines? First, its most remarkable feature. It is 100% pollution-free. It doesn't burn any type of fuel, nor does it emit smoke or harmful gases. It only uses air, something freely available around us, under pressure. That means zero greenhouse gases and no environmental harm. But there's more. A major hidden advantage lies in cost. While EVs require rare and expensive earth metals like lithium and cobalt, compressed air engines do not depend on such resources. They are made from inexpensive, commonly available materials, making them far cheaper to manufacture. And it's not just about cost savings. The production process is also much simpler. Since these engines don't rely on combustion, they don't need to be made from strong, heat-resistant, or heavy metals. This means they can be built using lighter and more sustainable materials. The use of lightweight materials not only reduces the overall weight of the vehicle, but also makes it quicker and easier to build. Another subtle yet important advantage over electric vehicles, EVs, is the cleanliness of the energy source. Even though EVs themselves are non-polluting, the electricity used to charge them often comes from coal or gas. In contrast, compressed air engines, which are not dependent on any electrical grid, emerge as a cleaner and more independent energy option. When it comes to operating costs, compressed air engines are a real winner. There's no need for petrol, no waiting in charging lines, just air, which is available everywhere. It simply needs to be pressurized, and the engine starts running. These engines burn no chemicals, consume no metals, and emit no toxic fumes. Best of all, when the air exits the engine, it goes out in exactly the same form as it entered. There's no waste of any kind. It wouldn't be wrong to call this a future-proof technology. But like every coin has two sides, compressed air technology has its drawbacks. While its simplicity and cleanliness are highly attractive, there are some technical limitations preventing large-scale adoption. The most critical issue is that the energy density of air is very low. Compared to batteries or petrol, air does not provide as much power. As a result, the engine needs to rotate at very high RPMs, which leads to frequent wear and tear of parts. Additionally, the torque produced by a compressed air engine is quite weak, making it unsuitable for tasks that require more power, like carrying heavy loads or driving on rough terrain. Since there is no liquid fuel involved, these engines are also difficult to lubricate, creating another maintenance challenge. Efficiency is another concern. While air might be free, the engines that use it are not very efficient. Most prototypes built so far have an average range of only 120 to 140 kilometers, which is insufficient for long-distance travel. Imagine if your car started giving a low air alert every few minutes. Would you trust it on a long journey? This range limitation was one of the biggest problems with early compressed air vehicles. They worked well within city limits, but the moment you hit the highway, range anxiety would leave you stranded again and again. And then there's the question of safety. Many early prototypes used regular steel tanks to store the compressed air. These tanks were heavy, which slowed down the car, and more dangerously, they were prone to accidents. If the tank was damaged or developed a leak, the tremendous pressure inside could cause it to explode. It felt like traveling in a moving pressure cooker. Imagine if your car started giving a low air alert every few minutes. Would you trust it on a long journey? This range limitation was one of the biggest problems with early compressed air vehicles. They worked well within city limits, but the moment you hit the highway, range anxiety would leave you stranded again and again. And then there's the question of safety. Many early prototypes used regular steel tanks to store the compressed air. These tanks were heavy, which slowed down the car, and more dangerously, they were prone to accidents. If the tank was damaged or developed a leak, the tremendous pressure inside could cause it to explode. It felt like traveling in a moving pressure cooker.